Hey all, welcome to Homeschool and welcome back to Class 11 Chemistry series. I am with the topic quantum numbers today, one of the most important topic of this chapter as well as for Class 11 Chemistry concerned. And this is important for competitive examinations also. Various questions have been asked from this topic in the previous board papers as well as for all the competitive examinations. So you need to concentrate this topic. As far as my observation concerned, many of the students feel difficult with this particular topic. It's because lack of concept clarity. Once you get that concept clarity, this is the most amazing topic and the most easiest topic of the entire class 11 chemistry. So I am here to bring that concept clarity of the topic in the easiest way. Let me connect the topic with the real life and then study it. Right? Let us enjoy learning this topic and definitely you will get 100% benefit out of this video. Watch till the end. And don't forget to post your opinion after watching this video. So all your doubts and confusions gets cleared once you watch this video. It may look little lengthy, but definitely I can promise you that you will get clear-cut explanation. Clear? Fine. So let me not waste your time. Quantum numbers. So try to understand what do you mean by this quantum numbers. I told you in my previous video that there is one famous equation called Schrodinger's equation where you have a factor called psi. And I told you this particular factor can describe everything about an electron. It is very much necessary to know every information about an electron. It's because these are the guys which can participate in chemical reaction, and it is very important to understand the location of an electron, the way it revolves around the nucleus, and the energies associated with the electrons. Okay, and I already told you that electrons are located in so-called orbitals. So the concept of orbits, what Bohr has introduced, was completely eliminated in this particular theory. It's because it is very well proved that electron moves in the form of wave, not as a particle, right? So the people started believing in something called orbitals. Schrödinger and Heisenberg told electrons are present in orbitals. There are many orbitals present around the nucleus. Why? Because there are many electrons in a particular atom. Okay, so what exactly we mean by these orbitals? It is just a space around the nucleus where we have maximum probability of finding an electron. I have very beautifully explained this sentence in my previous video. Just go and watch it out. You will get complete clarity on orbitals. Okay, so it is our duty to understand everything about the orbitals. We must know how many orbitals are there, what is the size of orbital, how electron can be located in an orbital. So every detailed information is given by the so-called quantum numbers. And how do you get quantum numbers? When you solve this psi value. Okay, so when you solve something called psi from Schrödinger's equation by applying lots of mathematics, you get certain numbers. Okay, so those numbers will be called as quantum numbers. Okay, so these are the numbers that will tell about, address of an electron. Say, I'm just using a simple language here just because to make you all understand. So in reality, quantum numbers are nothing but they are the numbers that are telling you about address of an electron. Okay, so address in the sense what? It is the location of an electron. Okay, so where exactly the electron is present, in which orbital it is present, what is the size of orbital, what are the energies of orbitals, so orientation of orbitals, everything you can understand with the help of quantum numbers, right? Okay, fine. And you see here, we have 4 different quantum numbers that we have to study in a detailed way. So the 4 quantum numbers are principal quantum number, the first quantum number, okay, and this is denoted with the letter small m. And the second quantum number is very, very important, azimuthal quantum number, okay, and this is indicated with the letter small l. And the third quantum number is magnetic quantum number. Magnetic quantum number indicated with the symbol Ml. And the fourth quantum number, which is also very important, called spin quantum number. This is spin quantum number indicated with the letter Ms. So remember the symbols of various quantum numbers, guys. N, which means principal quantum number, L, which means azimuthal quantum number, Ml, magnetic quantum number, Ms, spin quantum number. Okay, so these are the 4 different quantum numbers which tells you so many aspects of orbitals. Okay, fine. And let us first discuss about what do you mean by this principal quantum number. So imagine, guys, if I ask you your address, so what and all the things that you will mention? You will mention your town, colony, right? Colony, town, then district you will mention, state you will mention, and country you will mention. Right? Say if you are staying in a particular country, you know what is country means? It is just some space in this universe. Say for example, I live in India. What do you mean by I live in India? I actually live in a space that is present in this part of universe. So India is just some space or region present in a universe. Okay, say like that, electrons are staying in a space or region around the nucleus. Okay, so again, okay, I live in India, but where exactly you live in India? I will mention my state. Yes, my state is Karnataka. So I live in Karnataka. After mentioning the country, I have come to the state. So Karnataka is again a region which is there in a country called India. Okay, and again where in Karnataka? So in Karnataka, I will mention some district, right? I will mention some town. So what is this town? Town is again a small region which is present in a state. Isn't it? So this is how we are trying to find the exact location of electron. First we will mention the state. State is designated by the quantum number, principal quantum number. Principal quantum number is just like a state. Okay, so imagine your atom is one country. Atom is one country. So you have nucleus at the center and this is the empty region that is present around the nucleus. Okay, so here actually principal quantum number is talking about the states. So instead of calling as a states, I will call it as shells in this case. Okay, so practically when you talk about a country, country is divided into many regions, sub-regions called states. So principal quantum number will talk about the shells. Okay, and you know, once you spoke about the state, and inside a state you will have lots of districts, right? Say if you take up a Karnataka, you have Mysore district, you have Bangalore district, you have Mangalore district, like that. So many districts are there in every state. If you go to Maharashtra, again some districts. If you go to Andhra, some districts. If you go to Tamil Nadu, various districts, right? So azimuthal quantum number is actually talking about the district in which where the electron is located. Okay, so this is what we will actually call it as subshells, right? Fine. And inside a district you have a town, right? First I mention my state, after that I will mention my district, after that I will mention my town, right? So you are living in a town actually, right? So most of the time people can find you staying in that town. So town is what we mean by orbitals. Okay, so these are small towns or cities, right? Where most of the times we can find you in that particular region, right? So these towns or cities where exactly most of the times our electron is revolving is called as orbitals. Okay, so orbitals are small regions or spaces around the nucleus where we find our electron most of the times revolving there in that particular space. Okay, so principal quantum number is talking about the state, I mean the shells. Azimuthal quantum number will talk about the districts, that is the subshells. Magnetic quantum number is talking about the actual orbitals. Okay, so the entire space around the nucleus is first divided into shells. Okay, so shells are again divided into subshells. So subshells have orbitals. So inside the orbitals, these electrons are present. So orbitals are just a region, small regions. Just like in a state you have districts have towns and cities where you live, no? So small areas where the electron is living or revolving is your orbitals. Okay, so just let us try in understanding this much more deeply. Say, just for example, you will have so many states. I mean, initially you will have many shells. The entire region is divided into shells. Okay, you don't have a district boundary for these shells. Okay, just to understand the concept in a simple way, we do put this shells like this, but actually they are not the circular definite boundaries. Okay, they are just the regions. Okay, they are just the spaces or big regions in the entire space around the nucleus, right? So we have so many shells. So these shells are nothing but principal quantum numbers. So this is our first shell, n is equal to 1 we say, and this is our second shell, n is equal to 3. This is our third shell, n is equal to 3. Like that we can have the fourth shell, n is equal to 4. Okay, so principal quantum number is talking about the shells. So what will I write here? So this principal quantum number describes about shells. Okay, so n can have values from 1, 2, 3 and it goes on. Okay, n is equal to 1. N is equal to 1 means what, guys? It is K shell. The first shell is called K shell. N is equal to 2 in the sense L shell. N is equal to 3 in the sense M shell. And n is equal to 4 means it is N shell. So like this, for a shell, we have a name. This is K shell, this is L shell, M shell, N shell, and so on. Okay, so shell in the sense, it is not having the circular distinct boundary. It is just a region. Okay, so K shell is the region just around the nucleus. Say this particular region is very near to the nucleus. Whereas if you go to a second shell, the region, it's a quite bigger region and it is quite far from the nucleus. And if you go to a fourth shell, this is the region around the nucleus which is very far from nucleus. Okay, so just the immediate region around the nucleus is first shell, then this region is second shell, then this region is third shell, then the far away region is your fourth shell. Like that, the spaces are mainly divided into shells. N is equal to 1, 2, 3, 4, like that it can go on. Okay, fine. And here you have one important formula that you need to remember. If you know a n value, you can find out how many orbitals can be present in a particular shell. Okay, I told you, in each main shell, subshells are there. Inside a subshell, you have so-called orbitals. States have districts, districts have towns or cities, right? So these are states which again have subshells, that is districts. So districts again have towns or cities called, orbitals. Okay. So in the particular shell, if you want to know how many cities or orbitals are there, I mean in each state, if you want to know how many cities are there, for that we have a formula. So on this questions can be asked. Okay. So take down the formula. Number of orbitals in a particular shell can be calculated with this particular formula, n square. Say question, you can understand with this question. How many, if I ask you, how many orbitals are present in third shell, that is n is equal to 3. So in this particular state, if you want to know how many towns are present or cities are present, then what is the formula you will use? N square. Third shell, no? So n is equal to 3. You just have to do 3 square. 3 square is what? 9. So what is your answer? 9 orbitals are present in this particular state. Okay, in this particular shell. Okay, fine. And one thing you observe here, your principal quantum number also talks about size of orbital. Okay, or it will talk about the size of shell. You can also talk about size of shell. Right, as I told you, the first shell is actually a smaller, it's a small region around the nucleus. This is very near to the nucleus and this is actually a smaller region. Second shell, if you see, it's much bigger region. Third shell, fourth shell, if you go, it's again a quite bigger region. Right, so this principal quantum number will also give an idea about how small is the shell or how big is the shell or orbital in other sense. Okay, so usually the bigger shells will have bigger orbitals. Okay, if the shell is very big in size, inside that there are orbitals, right? The orbitals are also quite bigger. So indirectly, this number, principal quantum number, that is n value, will give an idea about size of a shell also. Okay, so this is all about principal quantum number. Now we will go for azimuthal quantum number. That means in each main shell, how many subshells are present. Okay, so in each and every state, we are trying to find out how many districts are present. Okay, so guys, as I have already told you, our azimuthal quantum number describes about subshell. Okay, so subshells are nothing but like a districts which are present inside a state. Okay, so this describes about subshells. Okay, so now we have to understand in each shell how many subshells are there. Okay, for example, if you take Karnataka state, we have 31 districts, right? If you go to Andhra Pradesh, there they have around 13 districts. Tamil Nadu, if you go, I guess it's around 38 districts. I'm not sure about the number, but I'm just guessing it. Okay, so every state has a number of districts. Like we have 31 districts in Karnataka. Like that, in every shell, we have to know how many subshells are there. Okay, so usually number of subshells is equal to n. Okay, I mean if n is equal to 1, okay, how many subshells are present? It is one subshell is present. One subshell is present in this main shell coming here. Okay, see, this is our first shell, K shell. So how many subshells are present in this K shell? There is only one subshell. Okay, so that is what we mean by. So if n is equal to 1, it means that one subshell is present. So if n is equal to 2, how many subshells are present in the second shell? In the second state, how many districts are present? It is equal to this number only. Okay, so 2 subshells are present. Clear? So let me draw here. So in this particular shell, that is n is equal to 2, we have 2 subshells. Okay, 2 lines I have drawn. And similarly, if n is equal to n is equal to 3, it means how many subshells are present in this third main shell? 3 subshells are present in the third main shell. Like that, the number of subshells will always be equal to the value of n. Okay, so if n is equal to 3, in that KLM, in the M shell, we have 3 subshells. Okay, so in the M shell, this is our M shell. So how many subshells are present? 1, 2, 3. Okay, can you tell me in the fourth shell, how many subshells can be present? Yes, it is 4 subshells can be present. 1, 2, 3, 4. Like that, 4 subshells are present. So if you have a fifth shell, can you tell me how many subshells can be present in fifth main shell? Post your answer in the comments. Clear? So this is all about guessing number of subshells in a particular main shell. Okay, fine. Now we have to understand, okay, in the first shell we have only one subshell. In the second shell we have only 2 subshells. But what are their names? Say in Karnataka, I told you 31 districts. What are those? We will identify with the names, right? Say 31 districts. So can you go on telling me the names of 31 districts? You will start from the district Bijapur, you know what, Bidar, Mysore, Bangalore, Mangalore, Davangere, Hubli, Ballari, you know. You will tell those districts with a particular name. So now we will have to give designation to the subshells. Okay, fine. See guys, understand carefully how I am giving names or designations to these subshells. Okay, see we all very well know in our first shell, that is in K shell, we have only one subshell. You know what do you call that subshell as? We will call that subshell as 0. So here 0 has a meaning. Okay, so this subshell is called with a letter 0. So 0 means it is yes subshell. It has a name yes subshell. Okay, so what is this? This is yes subshell. Clear? That is how you need to understand. And coming to the second main shell, we know that there are two subshells. See, two lines I have put. Two subshells are there. Okay, so what are they? They are L is equal to 0 and L is equal to 1. Okay, so 0 is a number for one subshell. 1 is the number for second subshell, okay, which is present in the second main shell. So L is equal to 0 means it has a name called yes. Okay, so this is yes type of subshell, and L is equal to 1 means it is P subshell. P subshell. Okay, so this subshell is called as yes, this subshell is called as P. Okay, but you will get confused. Here also yes, here also yes. But this is 1s subshell because this subshell is present in the first shell. So this is 1s subshell, this will be 2s subshell, and this is our 2p subshell. Okay, clear? See how I have given designation here. See, 1s subshell which is present in the first main shell. 2s subshell and 2p subshells are present in the second main shell. Okay, so these values are important, guys. What are the L values when n is equal to 2? L values are 0 and 1. L is equal to 0 means yes subshell. L is equal to 1 means P subshell. Okay, fine. And now coming to if n is equal to 3, what are the L values possible here? L values is equal to 0, 1 and 2. L is equal to 0 means yes subshell. L is equal to 1 means P subshell. L is equal to 2 means D subshell. Okay, so that means, see, in the third main shell, we have three subshells now. What are their name? Yes, P and D. Which is 3S, 3P and 3D. Okay, so they are 3S, 3P and 3D. Okay, so these are the names of the districts which are present in a third state. Okay, so 3S subshell, 3P subshell and 3D subshell. Very, very important. So similarly, when n is equal to 4 in our fourth shell, how many subshells are there? What are the values of L here? Values of L will start from 0. 0, 1, 2 and 3. See, 4 subshells. 0th subshell, 1 subshell, 2 subshell, 3 subshell. So this number is the designation. Okay. So L is equal to 0 means what? Yes. L is equal to 1 means P subshell. L is equal to 2 means D subshell, and L is equal to 3 means F subshell. Okay, so we will call it as n is 4, no? So we will call this as 4S subshell, 4P subshell, 4D subshell and 4F subshell. Okay, so these guys 4S, 4P, 4D and 4F. Okay, so this is how we give designation for subshells. Designation in the sense names. Okay, so what is the name of subshell present in K shell? It is 1S. What are the names of subshells present in N is equal to 2? It is 2S and 2P. So what are the names of subshells present in N is equal to 3? 3S, 3P, 3D. What are the names of subshells present in N is equal to 4? 4s, 4p, 4d, 4f. Okay, so this is what we mean by the designation of subshells. So you might be wondering, what is this S, P, D and F? They are just the names of subshell. Okay, so L is equal to 0. This is first subshell. Okay, what is its name? It is S. This is present in this particular subshell is present in 1, no, N is equal to 1. If it is present in N is equal to 1, it is 1s you say. If this 0 is present in N is equal to 2, then you will say 2s. Okay, like that. So here the meaning of the word yes means sharp. Okay, P is nothing but principal and D is nothing but diffused. These are actual elaborate names. F is nothing but fundamental. Okay, so a sharp subshell, in short we will call it as S. Principal subshell, in short we will call it as P, like that. So don't worry about these names. Okay, so these names were kept based on spectrochemical analysis. Okay, so don't worry about this. Just for your knowledge, let it be. These are actually full forms of S, P, D and F. Okay, so now that you understood S, P, D, F is nothing but designation for the subshells which are present in various main shells. Okay, so it's like we understood the number of districts present in a state and their names. So the number of districts in the first state is 1. What is its name? 1s. The number of districts in the second state is how many? 2. What are their names? 2s, 2p, like that. Okay, so this concept is also very important. Whenever L is equal to 0, you are talking about S subshell. Whenever L is equal to 1, you are talking about P subshell. Whenever L is equal to 2, you are talking about D subshell. Whenever L is equal to 3, you are talking about F subshell. L is equal to 4, G subshell. Anyway, about G and all we don't study for your level. So just stick on to L is equal to 3, that is F subshell. So these are the designation, different L values and different designation for that. Okay. So now we understood the subshells and their names. Now subshells are like districts. We got to know how many districts are present in the main shell and what are their names. Now each and every district will have cities or towns. In those cities and towns people live, right? So electrons also live in orbitals. So where are these orbitals present? Orbitals are present in subshells. So subshells are again divided into orbitals. And the number of orbitals present in each subshell and their names, everything is described by a quantum number, magnetic quantum number. So now we will discuss magnetic quantum number in detailed way. See guys, our magnetic quantum number, which is designated as small ml, right? This mainly describes about orientation of orbital. So what do you mean by orientation of orbital? See, orbital can be directed in a particular direction. It is placed in a particular direction. So this magnetic quantum number will tell you how many orbitals are present in every subshell and what is the direction of orbital. So these are the informations given by magnetic quantum number. Okay, so now first question is, how many orbitals can you expect in these subshells? So we have a subshell now 1s. So in this 1s subshell, how many orbitals can be present? Say this is your first state, right? In that only one district is there. In this district, if you want to know how many cities are there, how many towns are there, then you can identify by magnetic quantum number. Okay, so usually magnetic quantum number ml can have values from minus L to plus L. Okay, so this is really very important. So what do you mean by having values from minus L to plus L? Observe this. If L is equal to 0, okay, L is equal to 0 means what? Yes subshell. Yes subshell is present in every state. Yes subshell is present in every shell, isn't it? It is there in first shell, it is there in second shell, it is there in third shell, it is there in fourth shell. So in every shell, yes subshell is present. So when L is equal to 0, ML value is also 0 only. Okay, so that means only one orbital is possible for S subshell. It means what? One orbital is there in S subshell. Whichever may be the S subshell. S present in first shell, S present in second shell, whatever may be the number of main shell, S subshell always has only one orbital. So what is its number? It is 0. Okay, so only one orbital is there in S subshell. This is what we mean by. And observe this. If L is equal to 1, L is equal to 1 means what? I told you it is a P subshell, right? P subshell. P subshell is present from which main shell onwards? In first shell, N is equal to 1, you don't have P subshell. From second shell onwards, P subshell is there. 2P is there, 3P, that is in third shell, 4P in fourth shell, right? So from second shell onwards, your P subshell is there. Okay, so when L is equal to 1, ML values can be minus 1, 0 and plus 1. This is what we mean by having minus L to plus L values. Okay, so ML can have values from minus L to plus L. Okay, so what are the ML values? Minus 1, 0, plus 3. That means how many values are there? 1, 2, 3. What are they? Minus 1, 0, plus 1. So it means that 3 orbitals are there in P subshell. This P subshell can be present in second main shell, third main shell and fourth main shell, whatever it is. So always how many P orbitals are there? 3 P orbitals are there. What are they? Minus 1 P orbital, 0 P orbital and plus 1 P orbital. So usually minus 1 P orbital is called Px orbital. This is called as Py orbital. This is called as Pz orbitals. Okay, so always P subshell contains how many towns? Subshell means what? District. So this P type of district contain 3 towns. Okay, so 3 orbitals can be present. So actually Px means what? This is the orbital directed in x-axis. Py, P orbital, actually shape of P orbital is dumbbell. Okay, so you have dumbbell shape. That means your electron revolves something like this, in this fashion. So the shape we have given for that region is dumbbell. Okay, so this dumbbell can be located on x-axis. If it is located on x-axis, you will say it as Px. If it is located on y-axis, Py orbital. If the direction of this dumbbell is in z-axis, then we will call it as Pz. Like that, every P subshell will have 3 orbitals, Px, Py and Pz. Okay, fine. And now, let us talk about L is equal to 2. So, L is equal to 2 means what? Your D subshell. D subshell you will observe from which shell onwards? D subshell you will observe from third shell onwards. Right? So, when L is equal to 2, can you tell me how many ML values possible? minus 2 to plus 2. That means minus 2 is possible, minus 1 is possible, 0 is possible, plus 1 is possible, and plus 2 is possible. So how many values altogether? 1, 2, 3, 4, 5. That means 5 d orbitals. 5 d orbitals present there in, d subshell. So in d subshell, how many orbitals are present? Always 5. Okay, so this particular one can be called as dxy, this is called as dyz, this can be called as dzx, and this is dz square minus y square, and this represents dz square. Okay, so these are actually the names of 5 d orbitals. Okay, so actually the shape of d orbitals is double dumbbell. Okay, electron rotates like this. So double dumbbell shape you have, right? So depending on their directions, dxy, dyz, dzx, dz square minus y square, and dz square. These are the 5 d orbitals you have. Okay, see shapes of d orbitals, p orbitals, f orbitals, and s orbital we will discuss in the next video. Okay, now just understand the concept. Clear? So in the d subshell can be present in third shell, d subshell can be present in fourth shell. Whatever may be the d subshell, it will always contain 5 cities. Okay, so that is 5 orbitals. What are they? These are the orbitals. Okay, fine. And coming to L is equal to 3. L is equal to 3 means I already told you it is nothing but S subshell, isn't it? So when L is equal to 3, what are the ML values possible? Minus 3 to plus 3. Okay, all values from minus 3 to plus 3. So minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. So how many values altogether? 1, 2, 3, 4, 5, 6, 7. So altogether 7 f orbitals can be possible. Okay, so in F subshell always starts from fourth shell onwards, right? So this F subshell is a quite big subshell. It can accommodate, it can have how many orbitals? 7 orbitals you can have. Okay, so this is how we can identify the number of orbitals present in every subshell. Okay, so in S subshell you have only one orbital. We will call it as S orbital only. In L sub, if the subshell is P, okay, L value is 1, then how many orbitals can be present in P subshell? 3 are possible. In D subshell, 5 orbitals are possible. And in F subshell, 7 orbitals are possible. Okay, so each and every, say if you have 3 p orbital, these orbitals direction is different around the nucleus. So that is why we will designate with this, symbols px, py, pz, d orbitals. These are the names. F orbital names are very complex. We don't study them for your level. Okay, so just together you can say 7 f orbitals. Clear? So their shapes will be discussed in the next video. And now very important thing you need to understand is each orbital. Okay, so now we got to know orbital. First shells we got to know. Shells have subshells. Subshells how many and what are their names, everything we know. Now subshells have orbitals. Okay, so each orbital can give place for only 2 electrons. Okay, so in each and every city, how many electrons can stay? Only 2 electrons can stay. Okay, say for example, in the S subshell, you have only 1 orbital. No, in this 1 orbital, how many electrons can stay? Only 2 electrons can stay. Okay, so these points, what I am writing here is very important. Each orbital each orbital can accommodate 2 electrons. Only 2 electrons can stay in each orbital. Remember. So, can you tell me how many electrons can be present in S subshell altogether? S subshell has only one orbital, no? One orbital can have 2 electrons. So, your S subshell can, the entire S subshell can accommodate only 2 electrons. Okay, so S subshell can accommodate only 2 electrons. And now can you tell me how many electrons are can be present in P subshell? P subshell has how many orbitals? 3 orbitals. Each orbital can have 2 electrons. So 3 into 2, how many? 3 2s are 6 electrons can be present in P subshell. I'm talking about number of electrons in the subshells. Okay, so how many electrons can be present in P subshell? It is 6. Similarly, how many electrons can be present in L? L is equal to 2. That is D subshell. D subshell has 5 orbitals. So each orbital can have 2 electrons. So 5 into 2, 10 electrons can be present in this particular district. That is D district, D subshell. Similarly, F subshell has 7 orbitals. So, how many electrons each orbital can accommodate? 2. So, 7 into 2, 14 electrons can be present in where? F subshell. Like that, you can identify number of electrons present in different subshells. Okay, so hope the concept has become clear. About magnetic quantum number. Now we will discuss about the spin quantum number, and after that one big summary I'll give in the form of a table. Okay, so do watch the video till the end. With that, all your doubts and confusions will get cleared. See here. Now we understood that each orbital has how many electrons, guys? It is 2 orbitals. So we had got different types of orbitals, S orbitals, P orbitals, D orbitals with different shapes, isn't it? So whatever may be the type of orbital, each orbital will have 2 electrons, and electrons will not stay in a particular position, right? Say for example, if it is a p orbital, the shape is this, I said. Okay, so the 2 electrons will rotate. Both electrons would rotate in this particular region in this fashion. So this we called it as p orbital. But how do they rotate? Okay, say if one rotates in a clockwise spin, the other rotates in a anti-clockwise spin. You know what? Electron can rotate in 2 possible ways. For example, say our Earth rotations are of 2 types. One is Earth can rotate on its own axis, okay, and Earth can also rotate around the sun, right? So just like 2 different rotations for Earth, you have 2 different rotations for electron. One is electron can rotate on its own axis, and electron can rotate around the nucleus. Okay, so both electrons present inside an orbital rotates around the nucleus, and both electron can rotate around its own axis. Okay, say if this is one electron and this is another electron present in an orbital. Imagine this is the axis. This electron rotates in a clockwise direction. I'm talking about rotating around the axis. So if one electron rotates in a clockwise direction, okay, the other electron on its own axis rotates in a anti-clockwise direction. Okay, you can observe here, right? One is rotating in a clockwise direction, the other is rotating in a anti-clockwise direction. Each orbital has 2 electrons. No, both electrons revolve around a nucleus, but both electron must rotate on its own spin. No, something like this. Say electron will always rotate like this. One rotation is rotating around the nucleus. Other rotation you see rotating around its own axis. Okay, so if one electron rotates in a clockwise direction, the other electron rotates in an anti-clockwise direction. Okay, so the one which is rotating in the clockwise direction is called up spin. The other one rotating in the anti-clockwise direction is called down spin. Okay, so up spin is represented by giving plus half sign, and down spin is represented by minus half. Plus half means what? One electron rotates in a clockwise direction. Minus half means what? The other electron is rotating in an anti-clockwise direction. Okay, so the electrons present in a orbital can have 3 quantum numbers same. Okay, say for example, you take electron is present in 2p orbital. Okay, say here 2p orbital means what? Say there are 2 electrons in a 2p orbital. It means that the electrons are present in a second shell, right? And p subshell, they are present in second shell. Under the second shell, they are present in the p subshell, and in the p subshell there are 3 orbitals, right? Px, py and pz. So each orbital can have 2 electrons. Imagine both are present in px. Okay, so both electrons are there in px orbital. See here, these 2 electrons have same principal quantum number. These 2 electrons have same azimuthal quantum number. So what is the principal quantum number here? N is equal to 2. What is the azimuthal quantum number here? L is equal to 1. So they have same magnetic quantum number also. That is ML is equal to -1, 0 or +1. Okay. But do they have same MS value? No. One electron is having MS value plus half. The other electron is having MS value minus half. Okay, so the 2 electrons present in a single orbital can have same value for principal quantum number, same value of azimuthal, same value for ML, but it cannot have same value of MS. Okay, so MS will be different for the electrons present in a same orbital. If one rotates in a clockwise, the other rotates in a anti-clockwise. Okay, so that's all about the spin quantum numbers and the 4 quantum numbers. Now we will just summarize what we have studied so far. This will definitely help you a lot for understanding in a better way. Don't miss, do watch it. See guys, let us summarize everything in the form of table here. Okay, so the first one is n value. Let me write the n values, and for a particular shell, what are the subshells present? Okay, and then what are the ML values present, right? And again, like number of electrons in shell. Okay, shell. This also we will try to understand. Okay, see. So the first one is n is equal to 1, that is K shell. If n is equal to 1, what are the L values? L value is 0, right? So 0 means what? It is a S subshell. So what is the designation here? 1s subshell. Okay, so in the first shell you have only one subshell, that is 1s subshell. And how many orbitals can be present in this subshell? There is only one. So ML value is equal to 0. 0 means what? It has a meaning. 0 means what? It is one subshell, one orbital present in this particular subshell. Okay, and how many electrons can be present in this main shell? Can you tell me? Only one subshell and only one orbital. Each orbital can accommodate only 2 electrons. So 2 electrons are only possible. And there is a short trick to find the number of electrons. Okay, so the trick is 2n square. So you just have to do 2 into 1. 1 square is 1. 2 into 1, 2. So 2 electrons are present. Right, and coming to the second shell, we will talk about the second shell now. Our second shell is n is equal to 2. We will call it as L shell. Okay, so when L is equal to 2, there are 2 possible L values. One is 0, the other one is 1. Okay, so this 0 is called as s subshell. Which subshell it is? 2s subshell, and this is 2p subshell. This is what the designation. Okay, so when L is equal to 0, how many ml values possible? 0 only. Okay, 0 only. And then here, how many ml values can be possible? It is +1, 0 and -1, right? So this is px, py and pz. So 3 are possible. So can you tell me in total how many electrons can be present in second shell? In second shell, see here 2 electrons and here 6 electrons, 3 orbitals, 3 into 2, 6, no? Or you can apply this formula. 2 into what is the n value? N value is equal to 2. So 2 square. So 2 into 4. 2 fours are 8. 8 electrons can be present in second shell. Okay. Among the 8 electrons, 2 electrons are present in 2s subshell and 6 electrons are present in 2p subshell. Okay, so 6 electrons are present in 2p subshell. Again, 2p subshell has 3 orbitals. No, in each orbital 2 electrons are present. Okay, so likewise, can you do it for n is equal to 3? N is equal to 3 means it is m shell. So whenever n is equal to 3, what are the possible L values you will get? 0, 1 and 2. So this is what? 3s subshell. This is 3p subshell. And this is 3D subshell. Okay. So what are the possible ml values when L is equal to 0? 0. What are the possible ml values when L is equal to 1? Like how many orbitals can be present in 3p? It is -1, 0 and +1. That means it is 3px, 3py and 3pz, like that. Okay, and now when L is equal to 2, what are the possible ml values? -2, -1, 0, +1, +2. That means it is 2dxy, 2dyx and so on. dxy, dyz, dzx, dx square minus y square and dz square. Okay, like that. And here, can you tell me how many electrons can be present? Use the trick. 2n square, no, 2 into n value here is 3. So 3 square. So 2 into 9. 2 nines are 18. So 18 electrons can be present in third main shell. Okay, so among the 18, you know, the D subshell can have 10 electrons and here 6 electrons are located and here in this subshell 2 electrons are located, right? So 2 plus 6 plus 10, it is 18, right? And similarly, you can work for the last subshell that we studied, F, that is when n is equal to 4, okay, K, L, M, N, in your n shell. Okay, in your main state, fourth state, how many districts can be present? 4. What are they? 0, 1, 2 and 3. Okay, 0 means what? It is 4s. 1 means P, no? Which P? 4P. 2 means D, right? D subshell. So, which D subshell? 4D and 4F. Okay, so when L is equal to 0, what are the possible ml values? 0 only. And here -1, 0, +1. And here when L is equal to 2, what are the possible ml values? -2, -1, 0, +1, +2. So here what are the possible ml values? -3, -2, -1, 0, +1, +2, +3. Okay, like this. So here this subshell, 4s subshell can have 2 electrons and 4p subshell can have 6 electrons and 4d subshell, it has 5 orbitals, no? So 10 electrons and 4f subshell, 7 orbitals it has, so it can accommodate 14 electrons, right? So you add 14 plus 10 plus 6 plus 2. So those many electrons can be present in n is equal to 4th shell. Or you can apply this trick. 2 into n value is 4. So 4 square. 2 into 16. So 16 into 2, that is 32 electrons. Okay, like that. So as you go away from the nucleus, as the shell size increases, number of subshells present is more, so more number of electrons can be accommodated. Okay, so I think you have got a picture that electrons, where exactly they can be present and how they can be present, right? So in my next class, let us discuss about the shape of s orbitals. S orbitals possible is only 1 and p orbitals possible is 3. And how many possible d orbitals? 5. How many possible f orbitals? 7. So what are their shapes? Okay, and then how electrons will get filled up, and writing electronic configuration, everything we will learn in the next video, and do watch it. That is also very, very important topic. So thank you so much. With this, I am completing this topic. Meet you all soon in the next video, and do subscribe our channel to learn the concepts in a easiest way and in a detailed way. Thank you.